Hey guys, in this video, we're going to take a look at solving exponential equations. Now there are two types of approaches when solving exponential equations. But before we look at the examples, let's recall something. Now if we recall, logarithms and exponents are inverse of each other. If you guys remember the last video, we proved that exponential form and logarithmic form are inverse of one another by graph and x and y table. All right, so we're going to take a look at two examples where one of them we don't really have to use logarithms and the other one we're going to use logarithms. Let's take a look at the first one. So for example 1, all we're just going to do is we're going to change bases to solve exponential equations, starting with a. Now a, we have 2 to the x power equals to 64. So what I can do is I could try to find my way to rewrite one of the numbers as an exponential form so that the bases are the same. And all I need to do is just figure out the exponents. So for a, I have 2 to the x power equals to 64. Now I could rewrite 64 as an exponential form where the base would be 2. So 2 to the what power gives me 64. If you guys said 6, then you're absolutely right. So if I were to multiply 2 6 times, I would end up with 64. So I'm going to rewrite 64 as 2 to the x power equals to, 2 to the 6th power, equals to 2 to the x. All right, so we have 2 to the x power equals to 2 to the 6th power. So the bases are the same. Now I just need to make my exponents to be the same. So x has to equal to 6. So this will be my final answer. All right, so if I raise 2 to the 6th power, I get 64. So let's take a look at part B, where we have 3 to the 2x plus 1 power equals to 27. So just like A, I'm gonna rewrite one of these numbers as an exponential form, specifically 27. So 3 to what power gives me 27? If you guys said 3 to the 3rd power, then you're absolutely right. So I'm going to rewrite 27 as 3 to the 3rd power. And I'm going to rewrite these expressions. So 3 to the 2x plus 1 equals to 3 to the 3rd power. All right. So now that my bases are the same, I can go ahead and make the exponents equal to each other. So I have 2x plus 1 equals to 3. And all I need to do is I just need to solve my x, starting with subtracting both sides to 1. So I'm going to subtract both sides to 1. I get 2x equals to 2. And then if I divide both sides by 2, then x equals to 1. So x equals to 1. So if I were to plug x into my, if I were to plug in 1 into my x, 2 times 1 is 2. Add that to 1, you get 3. So you have 3 to the 3rd power, which equals to 27. So we're good. So now let's take a look at part C. So part C, we have 3 to the 32 to the x power equals to 8. Now this one is a little different than the previous two examples. Because if we take a look at A, we see we went from 2 to 64. And for part B, we went from 3 to 27. So my numbers increase. Now with this situation, part C, we go from 32 to 8. So how do we approach this problem where the number gets smaller? Well, even though the number gets smaller, we can still try to write these two as exponential form. So that way my bases are the same. For these kind of problems, my main goal is to make the bases the same. So we can change 32 and 8 to have the same base, starting with 8. Now 8, I can break it up as 4 times 2. And then between 4 and 2, I can break up 4 as 2 times 2. So I have 2 times 2 times 2, which can be rewritten as 2 to the third. I'm going to go ahead and rewrite that. So we have 2 to the third. Then I have 32. We know 32 could be broken up as 16 times 2. And then between these two numbers, we can break up 16 as 4 times 4. So with these two 4s, it can be broken up as 2 times 2 and another 2 times 2. So we have 2 times 2 times 2 times 2 times another 2. Or we can rewrite it as 2 to the 5th power. So we have 32, which can be rewritten as 2 to the 5th power raised to the x power equals 2 to the 3rd power. So I have 2 to the 5th raised to the x equals to 2 to the 3rd power. So I have an exponent raised to another exponent. Now, if you recall, what can we do with those two exponents? If you guys said multiply, then you're right. So we can just multiply 5 and x, and we would get 2 to the 5x power. Oops, excuse me. So 2 to the 5x power equals to 2 to the 3rd power. All right? So we have the bases to be the same. We have 2 on this side and 2 on this side. So now I just need to make my exponents equal to each other. So I have 5x equals to 3. And if I divide both sides by 5, then x is going to equals to 3/5. So this would be my final answer. X equals to 3/5. Now, to double check if we're right, I'm going to plug 3/5 into my calculator as an exponent. Right over here. So I have 32 up sign. I'm going to put in parentheses in between the fractions. 3 over 5. And we get 8. So we have 32 to the 3/5 power equals to 8. So my answer is right. X equals to 3/5. All right. So we took a look at 3 examples where we were able to change the bases to solve exponential equations. Now, there are going to be some example where it's not going to be, where we won't be able to use this technique. And instead, we're going to use logarithms to solve exponential equations. Because if you recall, logarithms and exponents are inverse of each other. Starting with a. So a, I have 3 to the x power equals to 4. Now, what I can do is I can use log to try to solve for my x. Remember, when solving an equation, when solving for a variable, you always want to do the opposite of the original inverse. And since x is being raised an exponent, I'm going to use log since it's the opposite. But I'm not going to use any ordinary log. I'm going to use the common log where my base is 10. So I'm just going to put log on the left side. So we have log of 3 to the x power. Now remember, whatever I do on one side, I have to do on the other side. So I'm going to put log on this side as well, and I have 4. So remember, I'm just using the common log where my base, meaning the number that would be in the middle, would be 10. All right? So I have log of 3 to the x equals to log of 4. Now, even though we were able to put log on both sides, we still have x as an exponent. But if we recall, there's a property for logarithms where we can move the exponent to the front, which is a power property. So all I'm going to do is I'm going to move x to the front. So I'm going to turn into x times log of 3 equals to log of 4. So now I have x being multiplied by log 3. All right? So now I just need to get x by itself by doing the opposite of multiplication, which is what? If you guys said division, then you're absolutely right. So I'm going to divide both sides by, log 3. So then x is going to equal to whatever I get if I divide both of these two. So I'm going to plug this in a calculator. So I want you guys to take out a calculator if you don't have one, or use your phone. So you have log of 4 divided by log of 3, and that should give you 1.26. So I'm going to round it to 2 decimal places. So x is going to equal to 1.26. All right? So x equals to 1.26. Right, so let's go ahead and do another example where we use the same technique. So we have b, which is 1,111 equals to 5 times 2 to the t power. Now, before anything, we see that we have 5 being multiplied by 2 to the t power. And I just want to get the exponent by itself, the exponential form to be exact. Now, what I'm going to do is I'm going to do the opposite of multiplying by 5, which is dividing. So I'm going to divide both sides by 5. So I get 2 to the t power. So then if I divide 1,111 by 5, let me see. Oh, I put 2 divisions. I get 222.2. So I have 222.2 on that side. So I have 222.2 equals to 2 to the t power. So now what I can do is I can just include log on both sides to move this exponent to the front. So I have log 222.2 equals to log 2 to the t power. And if you recall, by using the power property, I can move this t to the front. So I have t times log of 2, which still equals to log of 222.2. So I can get t to be by itself by dividing both sides by log 2. So that way, t equals 2, whatever decimal I get when I divide these two. Let's go ahead and take out my calculator. So you have log of 222.2 divided by log of 2. And that should get you 7.80. So I'm going to round it to 2 decimal places, which is 7.80. All right? So that would be my final answer for part B. If you wanted to round into 3 decimal places, that's fine. Just make sure that the decimals are within that range. All right, so we're going to take a look at part C, which we have 10 to the x power equals to 8.07. So what I'm going to do is I'm going to put log on both sides to get the exponent to be in the front. So I have log of 10 to the x power equals to log of 8.07. So with that being said, I can go ahead and use the power property to move this to the front of the line. So I have x times log of 10 equals to log of 8.07. Now, we're using common logs. From these 3 examples, we're using common logs, where my base is a 10. So for this one, I have log 10 of 10, or in this case, log 10. Now, if I were to convert that into an exponential expression, or if I plug that into my calculator, log of 10 would equal to 1, because 10 to what power gives me 10? Just 1. So even if I were to plug this in my calculator, so let's see, we have log of 10 That gives me 1. So log of 10 turned into 1. So I have x times 1 equals to log of 8.07. And if I were to multiply x by 1, I still get x. So then x is going to equal to log, whatever log of 8.07 is. So if I plug that in my calculator, if I have log of 8.07, I get 0.9. So I'm going to rewrite log of 8.07, and then if I plug that in my calculator, x is going to equal to 0.91. So this would be my final answer. All right. So if you guys still have any questions, you can always feel free to email me. Hope you guys have a wonderful day.